Hi, this is Phil from Simply Rhino, and in this video I'm going to take a look at file referencing in Rhino with block instances and work sessions. This video aims to give a basic overview of blocks and work sessions, but this is a subject that we cover in much more detail in our 3-day Rhino for Architecture class. Let's first take a look at block instances. One way of understanding blocks is to use the metaphor of components and assemblies. Here, the Rhino file we have open is an assembly that contains a number of components, all of which are referenced block instances. Blocks are especially useful where there are multiple instances of the same component in an assembly, as model and file management can become much easier to control. File size is another advantage. Here you'll see that the assembly is very small, 357 kilobytes. This is because the file contains no actual data, just links to the various component files. If we compare this to the same assembly made without block instances, you can see that the file size is now 637 megabytes. File size efficiency is, however, just one reason why using blocks could be a good idea. Blocks are also really useful if you want to create variations of components in an assembly, to show design alternatives, for example. Blocks also promote an efficient way of keeping component data up to date. Let's first take a look at how we propagate an assembly file with block instances. This is the assembly file of the space station loading bay into which I'm going to bring the components. I have a couple of pre-built layers and some curves that I can use to snap my components to. Let's now have a look at the file for the first component that I'm going to insert into the assembly. One of the common misconceptions is that a block instance needs to be created before it can be referenced into an assembly. Here we just have Rhino geometry. There's a blank controlling layer and the major components of the airlock door assembly all exist on their own separate sublayers. And this file can be brought into an assembly as a block. So let's go back to the assembly file and bring in the airlock door as a block instance. So I'm going to go to File and Insert, and the first thing I'm going to do is to navigate to my airlock door assembly file. I then get some options for the inserted file, and I can choose to bring this in as an embedded block, an embedded and linked block, or a linked block. An embedded block brings in the full weight of the geometry and maintains no link to the component. In other words, if I modify the component outside of the assembly, I'll have no chance to update this in the assembly. If I choose embedded and linked, then I bring in the weight of the geometry, but I maintain that rearward link to the component. So if, for example, I modify the component at a later date, I have the choice in my assembly of whether to update to the latest component or whether to keep the old component. The final choice is a linked block. This is the most file efficient means of using blocks because there is no geometry that actually comes into the file. There's merely a reference. And because there's no geometry in this actual file, of course, if I modify the component independently of the assembly, then the assembly, when it's opened, will always reflect the latest version of the component. I'm going to choose the active layer style here, and I'm going to choose linked blocks. Finally, this option, Read Linked Blocks from the File, maintains any links that the component file itself may contain. So, if the airlock door file itself contains linked blocks, we could propagate all of these links by enabling this option. I'm now going to hit the OK button, and I now return to the main insertion dialog. For the insertion point, I'm going to choose prompt, and this will position the cursor at the 000 position of the file that we are using to bring in as a block. I'm going to set the scale to uniform 1, meaning that I'm going to maintain the scale, and I'm choosing not to enable the rotation option. Then I'll go to the OK dialog, and my block instance will now come in, and I can snap this to my curves. You'll see that the layer structure of the component has been maintained, and I have the full visibility. However, there is one thing to consider when using linked blocks, and that is that the layer that is active when the blocks are inserted will also control the visibility. So for example, if I switch layer here and turn off the assembly layer, which was active, this will also turn off the visibility of the block. To get round this inconvenience, you can simply select the block and then right click on the top level of where the block should be, in other words O2 airlock door assembly, and change object layer. Now when I turn off the assembly layer, I now have the correct visibility in the file. If you want to have multiple instances of this airlock door in the file, we don't need to insert the block again. We can simply select the block and use the copy tools and copy this out inside of the assembly. So now I'm going to bring in another block instance, and this time I'm going to use a link and embedded block. So I'm going to go to Insert. I'm going to choose the ventilation panel 600 by 600, and I'm going to choose Embedded and Linked, and same settings that we had previously, and bring this part in, and I'm then going to orient this and copy and array it. Okay, so now these parts are in, I'm going to bring in some more block instances, and this time I'm going to revert to them just being linked blocks. So I've now brought in the remaining block instances. All of them apart from the ventilation panel are linked blocks. So let's just shade this up, and you can see now that we've got something similar to the assembly that we started with. Now inside of Rhino, the blocks are managed through the block manager, which we can view by going to Edit and Blocks and opening up the block manager. Here we can see all of the blocks that are in the file, and we can access the properties for that file. We can see that the airlock door assembly is a linked file, and we can see that the ventilation panel is an embedded and linked file. Also down here we have an option to choose what happens with embedded and linked blocks, and my option here is set to prompt when update required. So I'm going to close the block manager down, and I'm going to save this file. This file is slightly bigger than the previous one that we started with because we have an embedded block for the ventilation panel. Now I'm going to go back first of all to the airlock door assembly, and I'm going to make a change to this. I'll just remove a couple of handles and save the file, and then I'll reopen the cargo hold assembly. And because the airlock doors are linked blocks, then of course the geometry updates immediately because we don't have any reference for the airlock door in this file other than the file that we are actually referencing. If we make a similar change to the ventilation panel, then we'll see slightly different behavior. So I'm going to remove a number of these holes. So I'll go to Solid Tools and Untrim Holes, and I'll just pick a few of these. And when I've finished, I'll save the file and then open up the assembly again. This time, because we have a linked and embedded block that has been updated, we now get the choice of whether we want to update to the latest geometry now or whether we update later. So I'll choose Update Later, and you'll see that the ventilation panel here retains the old design. If at a later date I wish to update this geometry, I can go to my Blocks Manager. I can see here that the linked file is newer. I can pick this reference here and update, and the file updates to the latest geometry. Next, let's assume that I want to use a different version of this airlock door for a variant on the design scheme. So I have here a file which is already been completed, and you'll see this has a different handle configuration. Also, I've applied some materials to a couple of the parts. Now, materials have to be applied to the Rhino geometry, and materials can't be applied to the blocks themselves. But if you apply materials here to the Rhino geometry, blocks will support those material changes, and that includes plugin materials, for example, for V-Ray. So let's have a look at what we need to do to bring this door variant into our assembly. So I'll go back to the cargo hold assembly model, and because these files are linked and not embedded, the easiest way of doing this is to go to the Blocks Manager, to find the airlock door assembly block, go to Properties, and then simply change the reference to the new file. And then the one block is swapped out for the other. So this is a very efficient way of making changes to cladding, curtain walls, balcony elements, glazing, where you have repetitive geometry and you want to show variations on a theme. One of the advantages of embedded and linked blocks over linked blocks is that we have more flexibility in terms of in-place block editing. This is where we can easily change all of the instances of a particular block or component in the assembly without changing the source component itself. If we attempt in-place block editing on a linked block, then we have no choice but to change the source component. So let's take a look at making a change to a block in this assembly. I'm going to zoom in to the grill panels that are on the floor and also between the walls, and I'm just going to change to shaded view. This grill panel is the panel that I want to change. Now at the moment this is only a linked block, but the block manager in Rhino will allow me to change how this is referenced. So I can go to Edit, Blocks, Block Manager, I can pick Panel 4, I can go to Properties, and I can change this to an embedded and linked block. Hit the OK button and close. One of the changes that this will make is that it will make the file bigger. So at the moment this file is 3 megabytes. If I now save this file, you'll see that the file size increases to 4 megabytes because we now have real geometry in the file that is linked rather than just a link. Now, if I want to make changes to this component, I can go to Edit, Blocks, and Edit Block in Place. And when I have a linked and embedded block, I'll have two choices. I can either launch another copy of Rhino and open the component itself, or I can edit the component in position in the assembly, and of course this will permanently unlink the block definition. So I'll choose the latter, and you'll see when I do this that all of the geometry other than the object that I have selected becomes grayed out, and I can now edit this. So I'll just go in and extract this top surface. I'll remove these details here. I'll untrim, and then I'll select all of the geometry here and join this back together. When I've done that, I can hit OK, and the block has been edited in place, and you'll see all the instances of this are now updated. Okay, so as previously mentioned, we've now lost the rearward link from this file because we've edited this in place and not maintained that link. However, if we change our mind about this and subsequently I think, well, I preferred the grill panel as it was before, all isn't lost. I can go to Edit, Blocks, Block Manager. I can go to my panel here, which at the moment is not linked, and I can go to Properties, and I can find the original component, and then I can replace the modified component with the original component. So you can see that blocks give you a lot of flexibility in terms of how you can handle components in an assembly. Here we have a slightly different version of our space station cargo hold, where all the components are linked blocks, therefore giving us a very small file size. Although the components are all referenced in from external Rhino files, the links to these actually reside in the Rhino assembly file itself, so we could call these internal references. Rhino also has the concept of external references, which are called worksessions. In this case, the referenced files are appended to rather than referenced inside the Rhino assembly file. Whilst there is, of course, an overlap as to where one would choose blocks or worksessions as a means of referencing, you could generally regard worksession references as something that you would like to see and visualize, but not directly edit, move, or scale. In this example, if I was directly involved in the design of this particular cargo hold and my colleagues were working on adjoining modules, I could use worksession references as a means of viewing these files. If I go to File and Worksession and Manage, I can open the Worksession Manager and attach these files. So here I've got Bay B, which I'm going to attach. And you'll see this information comes in, and then I'll attach Bay C. Then I'll close the Worksession Manager, and as I zoom out, you can see Bay B and Bay C. The first thing to note about worksession references is that they are protected. So if I pick a component that is on a worksession and try to move it, it looks as though I can drag the component, but when I let go of the component, it just comes back into position. Similarly, I can't delete or edit this geometry. So it's a protected geometry. We'll see that we have full layer control, so I can turn off the whole of the geometry, or I can just turn off part of the geometry, pretty much like we do with Rhino geometry itself. But you'll see that these layers are grayed out. This gives us a clue that this is a work session reference. If there's a particular piece of geometry that I'm interested in, I can copy that into my active file. So for example, if I make a new layer here and give this a name, geometry, make this layer active, then I could take this component and go transform, copy, and use the InPlace option. And then if I hide my work session reference, I can see the copied geometry, which has now moved into my current file, thus giving me the ability to edit this in any way that I want. The biggest difference in work sessions compared to blocks is perhaps the way that the files themselves are saved. And the advantage of a work session over using blocks is that I have the choice of opening the assembly with or without bay B and bay C being appended. To save the work session file itself, I go to File, Work Session, and Save As. I can choose a location for this, and this saves as a small .rws file. So I'll give this a name and save that file. So let's have a look at how we can open the two types of file here. Let's start with a new blank file. And let's look at how we open a work session. So we go to File, Work Session, and Open, and then we choose our saved work session file. Now you can think of this work session file as just merely being a list of Rhino files, one of which is the active file, the others which are appended to the active file. So in this case, what happens is that I open the assembly file first of all, and then the two appended files are opened and appended to it. And if I save the file from inside Rhino by going to File and Save or Save As, I'm only saving the geometry that's actually inside the Rhino file. I'm not saving these externally referenced items. So to save these, I need to use the work session. Again, if we go back to a blank file, I can also open this on its own without the appended work sessions. So this is a big advantage. It means that I don't have to always have all the clutter of the additional components. Now, blocks and work sessions are something that we cover in much more detail on our architectural class, but they're also very useful when we come to do visualizations, because blocks and work sessions both support Rhino material definitions. As long as the material definitions are applied to the Rhino geometry, then whether we reference by blocks or by work sessions, those material definitions will be seen by the Rhino renderer or the plugin renderer. Thanks for watching, and if you have any comments or questions, please do leave them below. If you found this video useful, please hit the like button, and remember to keep up to date with the latest developments in Rhino for both Mac and PC. You can subscribe to this channel. Thanks again for watching, and I hope to catch up with you again soon in the next video.